Okay, so we're coming to the end of Chapter 9. We're going to do Chapter 9.7 tonight, and that's where we talk about different models of different data sets. We're only going to deal with 3 specific models. One's linear, that would be a line. One's quadratic, that would be a U. And one's exponential, and that would be that kind of curved really up really steep or really down really steep kind of curve. All right, so again, linear gives you the line. The equation has an exponent of 1. Quadratic gives you the parabola, the u, and the exponent, the highest exponent is 2. And exponential is where the variable, the x, is the exponent, and it's that curve that gets really high really fast, or it either gets really low really fast. So if we look at choosing a model by graphing, ideally we would graph these points ourselves. But they've already graphed them for us, so all we really have to do is look at the graph and figure out. But let's say that they did not give us the graph and they just gave us the point set. If that were the case, you would put it on a graph and then look at the graph. But since they already gave us a graph, we'll just look at it. And if we connected these, what we could see is an obvious U shape. So this one is going to be quadratic. And then if you'll look at B, you can see a curve down. So this one's going to be exponential. And then if you'll look at C, those points are in a straight line. So that one's going to be linear. Okay? Now, like I was saying, they don't always just give you the points. So for these problems, they're not going to give you the points. And I'm going to do number 1A with you, and you're going to do 1B on your own paper. So for 1A, I've got the point 0, 0, and then 1, 1, and then -1, -1/2, and then 2, 3. And that looks to me like it curves, but it doesn't go back up, so it's not quadratic. It's going to be exponential. And now I want you to work on 1B and put it on your own paper and then bring it to me tomorrow. Because there's no work to show for this one, you are just going to have to answer it and give me your best answer. I'm not going to give you the answer to this question. All right, example 2, if they give us a table and we want to choose the best model from the table, what we can do is we either can take differences or ratios. If you have the same difference between the y values, you have a linear function. If you have the same ratio between y values, y divided by x, then that's going to be an exponential function. And if you have the same second differences between y values, you have a quadratic function. So the first one, I'm going to show you differences between the y's. So this is going to go down 4, and then down 4, and then down 4, and then down 4. And each time for the x's, and you do have to make sure the x's are a constant too, they're actually going up 1. But you do need to make sure that the x's are changing the same every time. So since the first difference is the same, that's going to be linear. But if you'll look at B, the first differences aren't the same. I'm just going to move this over real quick. Okay. The first differences aren't the same because between the first and the second, it goes down 0.25. Then it goes down 0.75. Then it goes down 1.25, and then it goes down 1.75. So the first differences aren't the same, but the second differences are the same. So if I just move this over again, and I look at the differences between the differences, they are moving down a half each time. Each time they're going down a half, which means second differences are the same. So this one's going to be quadratic. Second difference is quadratic, and that's easy to remember because the function is going to be x to the second power is your highest exponent. So second differences is a quadratic, first differences is linear. And had the ratio been the same, had you been multiplying by the same thing every time, that would have been exponential. So hint, hint, forgot at number 2, if you're multiplying by the same thing every time, that is exponential. But if you have the same first difference, it is linear, and if you have the same second difference, it is quadratic. Okay, so that's all for the video. If you have any questions, you can contact me with Remind, which is probably the best way to do it. I don't ever check Twitter or Instagram for the classroom unless I'm trying to look at y'all's pictures. Make sure you bring me the questions tomorrow for your grade. And if you don't have any other questions, I'll see you tomorrow.